Welcome back everyone to another video, and in this one I'll be talking about this iSDT smart charger for your LiPo packs. Now this one's the Q6 Pro. It's one of the smaller models, goes up to 300 watts even in this package, and can go up to 6S cells or battery packs. And I have a small battery pack here. Now this one had an issue. I discharged it too much. So one cell actually went below the safe 3.2 volt limit, and it went down to like 2.5, which was pretty bad. And that's the main reason I bought this, was to, in such situations, be able to balance the cell back. Now it does have some damage on the cell, but at least you get some more life out of it, and we'll see what the damage is. This is a very interesting device. You can see how much damage the cell has and all of that stuff. So this is what I was using earlier, and there are a few differences I'll go through down the road in this video. But first, let's just go through a quick tour of what this is. Now this is the portable version, which means it is designed to be powered by a larger lipo pack. So the idea is you add your lipo pack here in the input section, and on the output section you add another lipo and charge that from lipo to lipo, or whatever the power source you want. And I wanted like a banana plug or barrel jack kind of thing for some projects, so I have added a XT60 to barrel jack converter here. And I'm not powering it with the lipo. We will take a look at that. I have extra lipo here, a bigger one. We will power it with that in a bit, but actually we should. I'm just using my adapter, and I've just created a XT 60 connector here, and that was easy to do, and you can power it from that as well. And so it is an interesting thing. It's powered by ARM CPU, and it actually has a big old heatsink for the MOSFET and the CPU, and then you have your um, fan here to get all the heat out, which is pretty interesting on such a small device. And you can, it has an interesting little headphone jack, which is not a headphone jack. You actually buy a separate cable, and you can then upgrade its firmware, and they do push firmware updates fairly often, which is good. So they are fixing and optimizing things all the time. And iSDT has like a bunch more products as well. So enough talking. Let's actually, what the box was pretty minimalistic. It had a screen protector, which I am very much thankful for, that they included something like that. Of course, my application has been less than good. And then they had like some instruction manual, and then a sticker booklet for some reason if I want to brand all my laptops and my phone with BatGo and iSDT branding. Yeah, I don't know why I would want to do that. Anywho, moving on. So let's power this thing up. I will show you charging this smaller battery from this larger power pack. This one's 11.1 volt 40C 3 cell jobby, and we'll just plug this one in, and this should power on. And I don't know if you could hear the fan whine quickly. And then it shows battery low, was I think I have set it to 12 volts. So I just, so long press, and you can actually go into its system menu, and small press will go into the charging stuff. So let me just select the input voltage correctly to 11 volts, I think 11.1. We'll just select it to 11, and then move back, and then our battery logo is gone, because our input voltage is now correct. And if I go here, you can see input is 11.5, output is 0, of course, and it has consumed 0 watts of charging, which is because we haven't connected anything. So this is a 2C sorry 2S battery, and its recommended charging amp current is 2.5 amps, and battery top voltage is 4.2. So that's a regular lipo. You can do LIHV lipo, lion life PB and NICD image as well. Life is interesting because I'm planning to use it in an upcoming project. They are heavier, but they're also way more secure, safe, and you can discharge them pretty low and they'll not corrupt. And talking about battery corruption or battery degradation, and this particular cell which I undervolted quite a bit, when I first plugged it in my initial voltage setting, so I'll just plug in the balance charger here and just follow the guides. There you go. So my battery voltage comes up pretty quick, and then I will also plug in the main lead, so other things it can also charge it properly. The other thing that happens is, if you can see, there's a discrepancy. It wasn't initially, now it's like gone back to its proper voltage, but initially when I connected it, there was around 2.2 ish millivolt, 2.200 millivolt difference between the two cells. And the reason is, again, um, since I depleted one of the cells very low, it's actually not very healthy. So let's get to it and start our charge process. So you see it's showing at 14%, and it has started to charge it, and it's moving up pretty quickly. So I'm just waiting for the internal resistance to update, because this is what tells how healthy your battery actually is. So I'm just waiting it to reach a point where the internal resistance gets updated. Here you can see all the stats. So we are charging the pack at 7.9 volts, 20 watts, and we are drawing 11 volts at 23 watts from our separate pack here. And I'll actually, in a second, once this is charged, I will add this pack to here, to the charging side, and I will charge it from the mains adapter. But for the time being, uh, it's charging pretty quickly. Now that's just because of the pack being such, or something else, I don't know. But here you can see the cell that was depleted has a much higher internal resistance than the cell that wasn't depleted, uh, below its minimum value, recommended value of 3.2 volts. And this means that when I leave this pack doing nothing, or even when this pack is being used, cell 1 is always going to get depleted faster than cell 2, and it will always be an issue for this pack. So I have to monitor it more carefully and make sure that it actually doesn't go beyond a certain point. And this is what happens when you start depleting a pack beyond the 3.2 volt um, range, is that its internal resistance starts to grow. The chemicals internally, they like form uh, a barrier layer, which means to charge it would be much more difficult, and it will internally discharge much more quickly even if it's being left alone. Right now it does a great job of balancing both the cells. I am very happy with that. And yeah, I have, so it was at 2.5, 3.2, and it just took a few seconds to get it to the point where both the cells were equally charged. So in the menu, while it's happening, you can actually adjust the current as well. So from the manufacturer specs, 2.5 is the um, 2.5 amps is sort of the recommended value. So whenever you buy a battery pack, just make sure that the manufacturer sends you a manual with it. And yeah, I the only thing that this is missing from the manual is the recommended internal resistance of the cell, or what sort of the good point or cell health kind of details, which are completely not present. I'm not happy about that, but you can see the difference, which is very interesting. And again, this is actual like smart charger. This one does do balance charging, but it's not truly smart. It cannot detect if there's a discrepancy between two cells, if one of the cells has to be charged at the higher current rate than the other. and stuff like that. Um, so I have just stopped it for a few seconds so that I can show you guys the system settings that are there. So you can select input power, which is just some options. I'm not sure why they even used it, but maybe if you have a cell that you cannot draw more than 310 watts from, you can add your limit there. And you can limit input voltage as well up to 7 volts. Um, and again, I have it at 11 volts. um, and you can select backlight, which can actually go into automatic mode. There's a little backlight sensor here, so if I shine a bright light into it, it will actually start to increase the backlight strength, and then if I remove the light, it will decrease. I mean, that's how automatic backlight works. So it's just a nice feature to have, I guess. And then from there you can go into volume, blah blah blah, firmware sharing, which actually means firmware update. System information will give you all the firmware info. And then self check, which is the calibration. So you remove this all the output battery stuff, and it calibrates itself. And I don't know what bad go is. I've like been trying to figure out, but like it just says bad go for some reason. I don't know. And we can like start the charging process once again, and it started from 38% instead of 45, so I think it's just ramping up, and it's back to where it was earlier. So I think it is charging pretty quick, which I'm happy about. But again, you should always monitor your charges. So I'll keep it rolling, and I'll be back once the entire process is done, just so that you guys can have like a nice little montage of the thing charging. And it's done. So fast charge done, zero point 0.3 amps, 310 mAh. It's a 360 mAh pack, so I actually had it depleted quite a bit. So 4.2 volts each cell. Okay, internal rest, I know it's done. Internal resistance is still around oh, is it discharging now? I know it's doing something. Internal resistance is still around 1 milliohm off, and then you have your other specs. So I think it's just keeping it topped off while it's connected. So it's giving 8.4 volts at one pot. It really doesn't need to, but since it's connected, it's topping it off now. Yeah, so there it is. There's the one lipo pack charging the smaller lipo pack. So now let's see how well it performs if I have a DC adapter plugged in. Now this is a 48 watt DC adapter, and so let me just change a few things in the menu. It's supposed to run at 12 volts, and we'll remove the wattage as is, and we'll press back, remove this connector, and plug in our battery pack. So I'll plug in the balance charge leads first. There you go. So all three cells are populated, and here I just need to select 3S. It automatically detected that. That's fine. Current is 2.5 amps. The same. Everything else will remain the same. Um, it's from the same manufacturer, and they have the kind of the same specs for all their cells. And I'll just plug this in. There we go. Uh, and I'll go and I'll select discharge all the cells to 3.2 volt, and you can also select storage, so it will actually discharge the cells to that, and we'll do it with this because I'm not going to use this pack. So we'll go with the storage uh, setting for it, and we have discharge. It discharges at a very slow rate. Now, of course, whenever you are dealing with discharge or charging of your battery, do reference the manual, and it can which has the proper discharge current. So this thing can be discharged at around 52 amps. So I think a slow zero point 0.2 amp discharge is still okay, and that is sort of the recommended discharge rate for these cells if you don't want to harm them. And we just start the discharge process. So now you can see the fan spin up, because of course it will only be discharging it by generating heat. So now all the fans is are spinning up, and I'm sure it's you guys can hear it on the mic. It's I think it's picking up fairly well. So we just wait for it to discharge completely, I guess. I think we can just select the discharge current from here, and I can go up to like 1 amp, and let's see how well that works. And here you can see the temps are pretty high, again because it's actually um, discharging it as heat. So it goes up to 50 degrees Celsius, and is charging it at 11 volts at 8 -8 watts. And yeah, so we'll just wait for to come down. Let's just try and push it to 2 amps now and see if that works. So it doesn't look like it's going more than zero point 0.7 amps, and I'm not sure if that's because of the heat. Maybe if I blow in some cool air somehow it might, but it doesn't look like it wants to go more than zero point 0.7 amps for discharge. So I'm not sure what's the limiting factor here. uh, I can actually try and maybe set it to 2 amps, stop the process and restart it. So I can just go here, it's at 2 amps, we start the discharge and see how no, it's still at zero point 0.7 amps, which is interesting. So you can just go ahead and keep that at points. I'll keep it at 1 amp, and wait for it to discharge, and I'll have a montage ready for you guys once it's in. I think it's interesting. And then once that's done, I will pick this up and put this into storage mode, so that it depletes it to around 3.8 volts, and then I will go back to this, and we'll start charging this particular pack. So I'm just waiting for it to discharge completely first. All right, so we are back with all the discharging done. So you can see all the cells are 3.23, which is I think a safe voltage to be at, and we have discharged over 670 uh, mAh, which is kind of double of that, which is just like 20% of what was here. So the next thing I wanted to try was to remove this and do the storage test, where it will discharge or charge your battery to a safe storage level. So that is what I'm trying to do. So I will add that here, add the balance charger for this battery because we just fully charged it and I want to store it for a longer term. So you can see although both the cells are 4.18 perfectly balanced as all things should be, and you know yeah, the other cell kind of fluctuated just now, but I think that's fine. And we can just go into discharge and select storage, and so it will just store it at 3.8 volts, and then that should be good for long-term storage. And you can just select start, and it will start to discharge it till 3.7 volts. Now it seems fine, about doing zero point 0.9 amps discharge. So I'm not sure what was wrong with this pack or why it was. Maybe it just detected it was overheating at that time. I mean the device was overheating, not the battery pack. The battery pack was fine. Uh, I don't know. Maybe we can increase that to 2 amps. Maybe that happens faster, or maybe it just selects it automatically. So no, it seems to be working fine at just 1 amp, and so I will actually go ahead and set it at 1 amp there. And I think it should just take a few moment to properly discharge, and then we can start charging the bigger bank and see how well it does that. Now I'm not going to go through the entire charging process of this power bank. This battery pack, and yeah. So I'm just waiting it to discharge till 3.8, and yeah, I think it should be fine. All right, so looks like the discharge is done. All cells are at 3.81 volts and took about 23 minutes for that to do. So let's disconnect that, and for our final experiment, we'll keep the Q6 Pro in storage mode, and we'll charge this larger pack up to the storage voltage of 3.8 volts. So I'm just going to unplug this and then plug this one in. And again, it's in storage mode. 3.8 volts, cell count is 3. I'll improve the current to 2.5 because we are charging, and we will press start. So now it starts to charge and resets because it's seemingly overloading um, my power supply. We are back after some technical difficulties. I have changed my power supply unit to a 12 volt 15 amp one as opposed to a 12 volt 2 amp one. And I think we should now be able to store charge this particular battery at 2.5 amps. Um, so let's see. We are at storage charge and at 2.5 amp. Let's see if this power supply can actually handle that much current. um, yep, looks like it, and that is working perfectly fine. um, I did a few days back buy a DC current clamp meter. So let's see if I think this is a good opportunity to test that one out. Let's see how much current is actually being drawn. According to this, we are drawing around 25 watt at 10 volts, which is 2.5 amps. So according to my zeroed that, and according to my clamp meter, yep, it's around 2.3 um, amps that's being drawn. Um, yeah, kind of makes sense. At 12 volt at 30 watt, 2.3 amps at 12 volt being drawn. That way we can get 2.5 amps at 10 volts. um, on this end, so I'm not sure if the actual main lead, these bigger ones are the ones that are used for charging, but I think we can still uh, test how much current is being drawn or being provided. So yep, there is 2.7 amps going through the main wire. So I guess these wires are just used for balancing, and all the charging is done through this one. Whereas on the older one, all the charging was done just through the balance leads, and that's it. So balance lead in this case is actually just for balancing. I think they just disable, like they use ground or something and not use this ground. Some weird crap like that. So yeah, the main grunt of the power is going through that one, and yeah, so we'll let it sit and see if how much time it takes to charge itself at 2.5 amps to a storage level of 3.8 volts per cell. Again, at 10 or almost 11 volts, 27 watts. All right, so looks like the storage charge is done. Everything's at 3.8 volts, uh, nice and balanced, and ready to store. So yeah, like a kind of a walkthrough through the whole thing. I'll do like a firmware upgrade down the line, and I hope I can make a video about it soon, so that all of you can see how it's done. Uh, yeah, pretty neat device. Does what it's supposed to do without much fiddling, and you just get a lot of options as well. I kind of like it. I think it's a good investment if you're looking into buying, looking into RC racing and playing around with LiPo, Life, and all of that sort of storage solutions, electrical storage solutions, not data storage solutions, of course. Yeah, I hope you enjoyed this sort of a walkthrough of the iSDT Q6 Pro. I really wanted to show you the insides of it to open it up, but I looked around, and to open it up, you actually need to peel off the front like plastic covering it has. It's all glued, so you need a heat gun, you need to peel it off, and it all gets messy. So it's a new unit. I don't really want to destroy it like that. It looks nice as well. So yeah, I wanted to show you guys the insides of this as well, but as I said, I would have put photographs and everything else of the innards of both of them, comparing them. This one's much more simpler, has like a basic micro for detecting a voltage and not charging. If the cells are out of balance, it doesn't do anything, it just errors out. So that's it, it doesn't have much smarts at all, whereas this does a lot of things very well. So yeah, I'm happy for it. Thank you so much for watching. I hope you all enjoyed this video, and I will see you all in the next one. Bye.